All right, guys, we're going to go over the review sheet today, and your test is tomorrow. Test is tomorrow. Looking at these first two here, are there questions on problems 1 or 2, or either one of those that y'all want to see worked? 1. So when we look at problem number 1, the first thing, again, with any of these here, we need to see if there's a greatest common factor. That's the first place we need to start. So if we look at 6, 36, and 71, well, 6 will go into both 6 and 36. But the question is with 71. Because 6 won't go into 71. Because 72. Because for it to be divisible by 6, it has to be divisible by both 2 and 3. 71 isn't divisible by 3 because if we add the digits together, 7 plus 1 is 8. 8's not divisible by 3, so 71 is not. 71 is also not divisible by 2 because it's not an even number. So there isn't a greatest common factor among those three there. But if we look at the variables, we have a cubed, a, and a squared, so we can factor out n a. And if we look at the b terms, b squared, and b squared. So we can factor out a, b squared for sure. So we still have 6. And if we take 1a away from a cubed, we're left with a squared. The b squared factors out completely. Minus 36. So if I take 1 away from the single a there, it factors out completely. The b squared factors out completely. Plus 71. If we factor an a away from a squared, we're left with a. And the b squared factors out completely. And what we have is this here. Now, if we want to rewrite it, we can, because we can say ab squared, because we'd have 6a plus a squared plus 71a minus 36. And that's as simplified as it gets, because it works out that 6a squared plus 71a minus 36 does not factor any further. The only difference between the first form and the second form is that the quadratic is written in standard form, not the other way. Questions on this here? Do number 2. We have 2 terms, yes? Now, if we only have 2 terms, because all the ones on the test are going to be factorable in some way, shape, or form. There's not going to be one that's just not factorable. There's 2 for sure that just have a greatest common factor that we pull out, and they stop there. But those, it's going to be a little more obvious that it is not factorable because we'll be dealing with kind of more 2 terms or something a little bit smaller. If we only have 2 terms, they're going to need to be either subtracted or added. If they are subtracted, the powers either need to be square or cubes. If they're added, they have to be cubes. Because we don't have a sum of perfect squares. We do have a difference of perfect squares, and here, x squared and b squared are perfect squares. So we need to see, is 36 a perfect square? Yeah, 6 times 6. So 36x squared would be 6x and 6x. 49, 7 and 7, so we'd have 7b and 7b. So this is a difference of perfect squares, which would be 6x plus 7b times 6x 7b. Because this is going along with the a squared minus b squared is equal to a plus b times a minus b. So if there's only 2 terms, we're either looking at a difference of perfect squares or some are difference of perfect cubes. It's one of those there. Questions on 1 and 2. You ready to look at the next one? Questions on 2 or 3?
2.
Okay. 4x squared plus 12x plus 9. Is there a greatest common factor between these 3 terms? No. Because if we look at it, all 3 terms do not have a variable. 4, 12, and 9 do not have a number that will go into all three. So there's no greatest common factor. So we have our two sets of parentheses with three spaces. We know this is going to be this form because, well, the only time we have the small and big is if we have cubes, which are going to be only two terms, or factoring by grouping, which is 4 or more. Really, for us here, it's going to be 4. So we have our two sets of parentheses with three spaces. We look for the signs. We look at the third term. If the third term is positive, the signs are the same and match the sign of the middle term, which is also positive. So we have plus and plus. Now we need the factors of the first and third term. So we know we'll have x and x. And with 4, we have 1 and 4 or 2 and 2. And it sounds like we want to try 2 and 2 first. With 9, we have 1 and 9 or, which one do we want to try first? 3 and 3. And again, for some of these here, it's always good to check the middle term, make sure we got it right. 2x times 3 is positive. 3 times 2x is positive 6x, so plus 6x. 12x, that's the middle term we wanted. Yeah, since it is the exact same term, we can say 2x plus 3 squared. I'll take either one. They are the same thing. For the other example 2, the one we did before, we wouldn't do that because the signs are opposite. Any questions on 2 or 3? So we'll get to number 6 here in a second. Are there questions on 4 or 5 first? Questions on problem number 4 or number 5? So 4 and 5 are really similar to the last one we did. It's just different numbers. Now number 6. So we have two terms, yes? Being subtracted. So it's either going to be a difference of perfect cubes or a difference of perfect squares. We know it's a difference because they're being subtracted. Or cubed root. Now, one of the giveaways for this one here is the x squared. X squared is a perfect square. It's not a perfect cube, because if it was a perfect cube, it'd be to what power? Third. Perfect cube, cubed roots are 3. Perfect square. So, is 64 a perfect square? It would be 8. So really, we can think of this as 8x squared minus what times itself is 1. So with our a squared minus b squared is equal to a plus b times a minus b. A in our case is 8x. B in our case is 1. So to follow the pattern, it would be 8x plus 1 times 8x minus 1. And that's it. So, any questions on 6 before we move to 7?
What's the formula for that?
This one here?
Yeah,
So for 6, is that there? So number 7, yeah, 6 and 2 are similar. 6 in the first 2, because there's 2 2s. Yeah. 7, we have 2 terms, yes? Is a cubed a perfect square? No, because the power is what? So we're looking at a sum of perfect cubes. So when we have 2 terms, there's a good chance it's a sum of perfect cubes. We don't have a sum of perfect squares. We just don't have that with 2 terms. So it's sum of perfect cubes. And we can verify that by taking the cubed root of a to the third, which is a. And we can take the cubed root of 1, which is 1. It's one of the nice ones. So this is the sum or difference of perfect cubes. It's our small and big. And we always find the signs first. And we find the signs for this one, it's the same, opposite, always end on a positive note. Same, opposite, always end on a positive note. So for the same, since this is a sum, our first sign is plus. Opposite is going to be minus. Always end on a positive note is plus. Now, part of the reason we took the cubed roots was, one, to verify that it is a difference or sum of perfect cubes, which we did, but it also gives us our main values. The first value is a, so in the smaller set of parentheses we have a. And our second term is, so in the first parentheses we'd have 1. So we normally have gone through in all the previous ones, we would do the first term all the way through, then the second term. But in that first parentheses, we'll have just that first and second term. Inside the bigger parentheses, to start off with, we'll have the first term squared, which in our case is a squared. In the middle, we'll have the first term to the first power, which is just going to be a. And in the third spot, we have a to the 0, which is going to just be multiplying the second term by 1, which we don't really have to put it in. Now we need to use the second term. Well, with a squared, we'd have 1 to the 0, which is just going to be a multiplication of 1, which really doesn't do anything or add anything to it, so we don't put it. In the middle, we'll have the second term to the first power, which is 1 to the first. We include it. It doesn't do a whole lot because it's 1. And in the last one, we'll have the second term squared, or 1 squared. Now, we do need to simplify a little bit. It's not going to affect the first set of parentheses because that's just going to be a plus 1. In the bigger set, we have a squared, which is just a squared, minus a times 1 is a, plus 1 squared is 1. And we have this here. A plus 1 times a squared minus a plus 1. Questions on this one here? Because 1 squared, 1 times 1 is just 1. We'll look at another one where the first and second terms aren't as simple as this here. So we'll have to jump ahead to 12, because I think that's the next one with cubes, or do you guys want to look at 13? 12. Now we need to see if we can take the cubed root of these two terms. Cubed root of 2,197 x cubed and the cubed root of 216. So you can grab the calculator, either one. Let me say 3 second cubed root, 2,197, I believe. 2,197 is 13. So it is a perfect cube. So we have 13, and then we also have x, because the cubed root of x to the third is just x. Now we also need to find the cubed root of 216. 3 second 216 is 6. So these are our two perfect cubes. So it is a difference of perfect cubes. Because we have two terms, so we're looking at one of those, and since x is to the third, it has to be a cube. Now our setup for this here is going to be 3 spaces and 5.
So you'll always do 3 spaces.
Sum or difference of perfect cubes. Because sum or difference of perfect cubes, one part is what we call linear. Both terms are going to be to the first power. And then a quadratic, where we have an x squared, or a variable to the second power. Now our signs are going to be the same, opposite, always end on a positive note. So since we're talking about a difference, the same would mean we'd start off with a minus. Opposite would turn it to plus, always end on a positive note, so plus. So minus, plus, plus. Questions on this here? Now for this one here, we can go on and put the first and second term into that first parentheses. We've always done first, but we don't have to follow that. It's just a pattern to get into. Our first term is 13x, because that's the one that came first. The second term is what? Our first parenthesis is going to be 13x minus 6. Now in the second one, our second set of parentheses, our first term is going to go square first, not there. So the first spot is going to be 13x squared, that first term squared. In the middle term, it's going to be to the first power. And in the last term, it would be to the 0 power. Anything to the 0 power is 1. The only exception is 0. Now our second term, with the 13x squared, it would technically be to the 0, which is just going to be 13x squared times 1. Doesn't really add anything to it. In the middle, we'll have 6 to the first, our second term to the first power. In our last one, we'll have 6 squared. Questions on how we got this set up? Now we just need to simplify. So 13x minus 6 is fine. 13x squared, 13 squared is 169. The x squared is x squared. We're squaring both terms. Since there's a single term being squared, we just square both terms. Plus 13 times 6 is x plus 6 squared is, and that's it. Questions on how we got to this here? Any other questions on this so far? Questions on 13, 14, or 15 before we go back to the previous 4? 13. So the first thing we can do is, so if we look at this here, we do have 2 terms, yes? And it's a sum. So that tells us that most likely, if we can factor, it's going to be a sum of perfect cubes, because we don't have a difference of perfect cubes. And again, the only factors that we deal with that have 2 terms are either going to be a sum of perfect square or sum of perfect cubes, or difference of perfect cubes, or difference of perfect squares. We know it's not a difference of perfect squares, 1, because it's a sum, and 2, a and b here are both to what power? 3. If it's a difference of perfect squares, it has to be to a second, squares power 2. Now, we can grab the calculator and do the cubed root. I think it said 375. 375 is not a perfect cube. Is there a number that will go into 375 and 192? Will 2 go into both of those? So the next number after that is 3. Will 3 go into both of those? So to figure out 3, we add the numbers together. 3 plus 7 is 10, plus 5 is 15. Is 3 divisible by 15? Or sorry, 15 divisible by 3. Yeah, so that means 375 is divisible by 3 for sure, yes? Well, 9 would be the next one, but 15 is not divisible by 9. So let's try 3 first. So I will factor the 3 out. 375 divided by 3 is 125. A to the third. Plus 192 divided by 3 is 64. Now, is 125 a perfect cube? I think so, and I think we've used it a few times by this point. 5. Is 64 a perfect cube? And it is 4. So the cubed root, 125a cubed, 5a. The cubed root of 64b cubed is going to be 4b. So because it has variables in both, we're going to end up having variables in all 3 spots. Or all the spots inside the parentheses, except for the signs, obviously. But questions on anything we've done so far? So same, opposite, always end on a positive note. So since we started with a sum, it's going to go plus, minus, plus. Now in our case here, our first term is what? 5a. So in our first spot, we can put 5a. What's our second term? 4b. So the first parentheses is going to be 5a plus 4b. Now plugging in the first term across the board, in the first spot we'd have 5a squared. In the middle we'll have 5a, and in the last one we don't have it. We don't have to put anything there. For the second term, don't put anything in the first. The middle would be 4b to the first, and in the last one we have 4b squared. In the bigger parentheses, 5a squared. Well, 5 squared is 25. And we have a squared. We're squaring it term. We're multiplying it by itself. 5a times 5a is 5a squared. Minus 5a times 4b. 5 times 4 is, and we have ab. Plus 4b squared. 4b times 4b, or 4 times 4 is 16, and we have b squared.
If you've already squared it, why do you have to put the square root in the final answer?
For which one?
Like on the 4b squared?
So it's 4b times 4b.
Yeah, but why do you keep the square on the final answer if you already squared it?
Because b times b is?
B squared. Oh, okay.
Yep.
Oh.
Because the number is squared. 5 squared, 5 times 5 is 25. Now we need a way to signify 8 times a, because we don't have a specific value for a, but we do know that it's being multiplied by itself. So we leave it as a squared or b squared. Questions on these here? 14 is not any different. It's just finding what the cubed root of 729 is and then following the same method that we've been doing. So any other questions on 12 through 15? We good with 12 through 15? Yes? So before we move forward, we're going to go back one and look at 8 through 11. Are there any questions on problems 8, 9, 10, or 11? Or do we feel good with these here? Yes? Number 11? Mm-hmm. And I think is 10, if you look at the answer key, is 10 not solvable? I feel like 10 is not factorable. Yeah, it's just 36x squared plus 49. Because again, we can't have a sum of perfect squares without its I, if it's not real. I meant for this to be a minus when I originally wrote it up, but I left it because I accidentally put plus. It just doesn't work. It's not factorable. 11, if we look at it, now the first thing we should be always looking for is a what? A greatest common factor. Now, looking through these 3 terms, there is an x squared, because all 3 have a variable, yes? X to the 4th, x to the 3rd, and x squared. So all of them have greatest common factor of x squared. We can pull 2 out of every term. Now the next question is there a common greatest common factor with 49, 3, 43, and 7? 49 and 7 do, yes? The common factor is what? Now the question is if 343 is divisible by 7. 343 divided by 7 is 49. So, wait, 6 and 4? Oh, yes, that works for 3 and 9. The sum of the digits dividing by it works for 3 and 9. It doesn't work for 7. I'd have to look back because there is a trick for 7 because it's multiplying the last digit by, I think it's 5, and adding them together. I'd have to look it back up. But 7 does divide into all three. We can pull it out. It is a factor of all three terms. If we do 49 divided by 7, we have 7, x to the 4th divided by x squared, x squared. If we pull 7x squared out of 49 x to the 4th, we're left with 7x squared. Plus 343 divided by 7 is 49. If we take x squared away from x cubed, we're left with x plus 7x squared factored out from 7x squared is 1. That's it. Because we can check to make sure that this here doesn't factor. Our b squared minus 4 times a times c. This is just a way to check to see if it's factorable or not. And so I can grab a calculator. Second square root, 49 squared minus 4 times 7 times 1. If we get a decimal, a non-repeating, non-terminating decimal, really decimal at all, for the most part, it's not factorable. It's going to tell us that the solutions for that are here. They're going to be irrational solutions, which means we won't factor it any further. The kind of giveaway for me here that's hinting towards it not being factorable is because, again, to find the middle term, we're multiplying the factors of A, the factors of the first term, by the factors of the third. The only factors of 7 are 7 and 1, and the third term are just 1 and 1. So there's no real way for us to multiply 7 and 1 by 1 and 1 in any combination and somehow get to 49. It's a little too big. So that's it, and I believe the answer key kind of will agree with that. Any questions on this here? Yep. We good with 10 and 11, 8 and 9? Yes? Questions on 16, 17, or 18? Questions on 16 through 18? So we have a sum of, and we have two terms, x to the third. So there's a good chance this is a sum of perfect cubes. And we can make sure by taking 8x cubed, cubed root of it, and the cubed root of 27. If we type the cubed root of 27 into a calculator, we will get 3. If we type the cubed root of 8x to the third, cubed root of 8 is 2. Cubed root of x to the third is x. Yep. You're welcome. Now, grab our two sets of parentheses with 3 spaces. And our signs are going to be the same, opposite always end on a positive note. Since it was a sum, we start out with plus. Opposite would be minus. Always end on a positive note would be plus. Now our first term is 2x. Our second term is 3. So in the first set of parentheses, we'll have 2x plus 3, first term plus second. And the bigger, we're going to have our first term squared, so 2x squared. And then 2x in the middle. Our second term will have 3 in the middle. And in the last spot, we'll have 3 squared. Any questions on how we got to this point here? Bless you. Now to simplify this a little bit, the 2x plus 3 doesn't really change. And the bigger one, 2x squared, well, 2 squared is 4. And x squared is x squared. Minus 2x times 3 is 6x. Plus 3 squared is 9. So we get 2x plus 3 times 4x squared minus 6x plus 9. Any other questions on these three here before we move on? Almost the last set. Questions on 19, 20, 21, or 22? Or really we can say 19 through 26. Really? Huh? Yeah. We can do 25. Now, 19 and 20 are just our greatest common factor, 2 sets of parentheses, and solving from there. 21 is the exact same as 19 and 20. Look for greatest common factor first, pull it out, and then go through our steps. 23 is a difference of perfect cubes. Pull the greatest common factor out first before you start it. 25. One of the giveaways for 25, 26, and 25 and 26 is we have how many terms? 4. There's only one type of factoring that we cover that has 4 terms, and that's our factoring by grouping or greatest common factor twice. So if we look at 25, we can kind of group them together. First 2, second 2 terms. So if I look at the first 2 terms, I'm looking for what's in common. What's going to be the greatest common factor between those 2 terms? What will go into both 25v cubed and 5v squared? 5v squared, because 5 will go into both 25 and 5, and v squared will go into both v cubed and v squared. So we'll take 5 out of both. So 25 divided by 5 is 5. And if we take v squared out of v cubed, we have v plus. If I take 5v squared out of 5v squared, what do we have? 1. Because when we factor things out, we're dividing it. 5v squared divided by 5v squared. Anything divided by itself is 1. Plus, because we can't, if we divide something out completely, we get left with 1. There's no way to get 0 when factoring out, unless the original term was already 0. Now, we need to see what's in common with 30v plus 6. 6. 30v divided by 6 is going to be plus 1. And really also what we're aiming for is those 2 sets of parentheses to be the exact same. And since they're the same, we can factor them out. That's also why I call it greatest common factor twice, because we did it once already. Now we're going to do it again. And this time we're going to factor out 5v plus 1. Because if I divide it from the first term, all I'm left with is plus, and I do it in the second one, I'm left with 6. And that's it. Any other questions on 25? We go to 25. Questions on, any other questions on 19 through 26? We good with these here? Okay. We ready for the last two? Questions on them? Okay, just look very focused on that, I think 26. Okay. Questions on 27 or 28? 27. So we have two terms, yes? One of them's a cube, because we have x to the third, that's a perfect cube, and one of them's x squared, because they have a greatest common factor. So we know x squared is going to be part of the greatest common factor. X cubed and x squared, we can pull that out. Is there a greatest common factor between 12 and 144?
12x squared.
So 12x squared is the greatest common factor. So 12x squared pulled out of 12x cubed. Well, 12 divided by 12 is 1. X cubed divided by x squared is x. If I take 2 away from the 3, we have 1x, or we can just say x, minus 12. 144 divided by 12 is 12. X squared divided by x squared factors out completely. That's it. Any questions on these here? Any other questions on any of the problems, the one that we've already passed? Yes. 24. 168 a cubed b squared minus 9ab cubed c plus 117 a squared b to the fourth. There is something in common with all three terms. Because really, where we should start off with any of these is greatest common factor. So let's see. So 1 plus 8 is 9, plus 6 is 15. So 15 is not divisible by 9. 9 is 117. 1 plus 1 is 2, plus 7 is 9. 9 is divisible by 9. So the second and third are divisible by 9, but 186 is not. It would need to be 189. 189 would be the next one that's divisible by 9. Because if we look at 186, 1 plus 8 is 9, plus 6 is 15. The next number after 15 that's divisible by 9 is 18. So it's 3 more. So we could add the 3 to the 6. So 189 would be divisible by 9. So I just add the 3 in one of those spots. Or 486 is, or 216. But 3 does work because 186, 15 is divisible by 3. Now we have a cubed, a, and a squared. So how many a's can we factor out? It's always the lowest power of the three terms. So first power is the lowest one, so that's how many we can factor out. Now we have b squared, b to the third, and b to the fourth. B squared. The middle term has c, but it's the only one that has c, so we can't do it. Now 186 divided by 3 is 61. No, 62. 62. Now if I take 1a away from a cubed, I'm left with a squared. B squared divided by b squared, or b, if I factor b squared out of b squared, it factors out completely. We could say it's multiplying by 1, but that really doesn't tell us anything because 62 times 1 is just 62. Minus 9 divided by 3 is 3. If I factor an a from a, it's It simplifies out to 1. Multiplication 1, we don't have to write it. If I factor a b squared out of b to the third, we get. So we have that for b because we took 2 away. And then we will still have the c term. Plus 117 divided by 3 is?
39.
If we factor an a from a squared, we have a. And if we factor b squared from b to the fourth, we're left with. And that's as far as it goes. We can't do anything further. Kind of a giveaway is the c term specifically, because for us to have a middle term, the first or second has to have it. So that's as far as it goes. And the fact that the third term has ab squared, it kind of throws everything off. And that's it. That's all we have to do for that one. Yes. So guys, your test is tomorrow.